subtopic number 4, which is on energy stored in an inductor. So for this one, just apply the energy stored in an inductor lah. You don't have to know how to derive this, but if you want to, you can just Google it lah to understand it. Okay, so the inductor is a circuit element. It can either be a coil ataupun solenoid lah. It has that has a large inductance. So function of an inductor is to control the current and to store energy in its magnetic field. So this is the symbol of an inductor, and this is the formula. So let's look at the example number 9. A coil has an inductance of 30 millihenry. So this is 30 millihenry, resistance of 0.25 ohm. If the potential difference of 12 volt is applied across the coil, calculate the energy in the magnetic field of the coil. So we know that energy is equal to half Li square. So we have the value of L, we just do not have the value of current. But we know that Ohm's law states that the formula of Ohm's law is V is equal to IR. So I is basically equal to V over R. So just substitute V over R di sini to get the energy in the magnetic field of the coil, which is equal to 34.56 joule. Okay, all right. Example number 10. We have a 25 centimeter solenoid, has a cross-sectional area of 15 centimeters square, energy of 0.022 joule is stored when a current of 8 ampere flows through it. Determine the self-inductance of the solenoid. Sorry. So we know that we have the formula of solenoid, but if we look at the formula of solenoid, which is apa dia minta? Dia minta self-inductance of the solenoid L. So dia minta L lah. Sekarang ni kita punya information that we have is only the area, the energy dengan the current dengan length saja. So this here is not enough since we do not have the value of number of turns. So apa yang kita buat is kita akan guna the energy punya formula to find L. So U is equal to half Li square. So L is gonna be equal to 2U over I square lah. So di sini kamu akan dapat the self inductance to be equal to 6.88 times 10 to the power of negative 4 Henry. Okay. Question A pula. Question B pula. Total flux linkage passing through the solenoid. So linkage, total flux linkage is this. Total flux linkage ka dia minta? Total flux linkage. Ka magnetic flux je. Wait Okay, so total flux linkage is gonna be N phi, right? And we know that L is equal to N phi over I. So Li is gonna be equal to N phi, which is basically the total flux linkage. So the total flux linkage is gonna be L times with the current, which will then give us 5.5 times 10 negative 3 Weber. Okay, so that is total flux linkage, and the number of turns. So the number of turns kita akan guna. I'm just gonna. So question C, the number of turns, we can use solenoid punya formula, which is mu naught N square A over L. Okay. So rearrange for number of turns, you will get L, italic L, mu naught A, square root there, and you will get the number of turns to be equal to 302 turns. Alright, okay. So that is on example number 10, and that's all for subtopic number 4.